Okay, so let's finish this one up. So part D, we have all the terms written without parentheses. And notice what happens when they get combined. We have an 8, a -3, and a -5. Well, if you do 8 minus 3 minus 5, all of those real numbers end up canceling out. Now let's look at the imaginary. So we have -5i minus 5i, that'd be a -10i, plus a +10i. Those also end up canceling. If everything cancels, it's just 0. So that's what you should have gotten in part D on the last video. So now let's move on from addition and subtraction and go on to multiplication. So when you're performing multiplication for complex numbers, you want to make sure that whenever you see an I squared, that really represents -1. And you perform multiplication just like if you had an x. Again, we treat I just like we would treat any other variable like x. So let's look at something without imaginary, and then we'll add the I in. So let's look at these multiplying binomials here. So we have 2 plus 3x, 4 minus 5x. So a couple ways you could do this is to FOIL, which I have written here, where you do first, so 2 times 4, 8. Outer, 2 times -5. Inner, 3x times 4. And then last, 3x times -5x. So notice I get all these terms, combine the two that are like, because they both have x, and we get 8 plus 2x minus 15x squared. Another method that may be easier to see is that box method. So it's 2 plus 3x, and then 4 minus 5x. So to do the box method, if you like that method, you basically line up the rows and the columns. So like right here, this is 4 times 2. That gives us the 8. 4 times 3x gives us the 12x. -5x times 2, -10x. -5x times 3x, -15x. Again, combine like terms, these both have x's, so we end up getting the same thing. So there's two methods to this. So feel free to use either method when you are using it with an I. So let's look at a problem with complex terms. So with multiplying complex numbers, in this example, we have 2 plus 3i, 4 minus 5i. It's the exact same problem that we had over here with multiplying binomials. The only difference is instead of x, we now have i's. And remember, we treat I just like any other variable. So down here, we could do FOIL, or we could do the box method. So let me get back to it. Okay, so if we FOIL, doing first, outer, inner, last, we would get all of these terms. Now notice, two of the terms have I, they can be combined to get that plus 2i. This other term has an I squared. Okay, so remember, I squared equals a number. I squared is not a variable. It equals -1. So anytime you see that I squared, you should really be plugging in or substituting in a -1. So let's do that right here. So what we're going to do is we're going to keep 8 plus 2i, but right here, this is -15 times a -1. So this becomes -15 times a -1. What happens when you do a negative times a negative? Well, when you do a negative times a negative, you should get a positive. So right here, we really have 8 plus 2i, and this is going to be a positive 15, because -15, -1 would be a positive 15. Well, again, we have two terms to combine, the 8 and the 15. So our final answer should be 23 plus 2i. That's our final. Now, if you'd done the box method instead of FOILing, the same process is used in the beginning of the problem. Like you still multiply, like 2 and 4 is the 8, 4 and the 3i is the 12i. Like you still get all those same terms. And notice you will still get the 8 plus 2i minus 15i squared. You then would substitute in, and it simplifies also to 23 plus 2i. So the box method is just another alternate method if you don't want to use FOILing. So now that we've seen how multiplying binomials is just like multiplying complex numbers, let's do one more example together and then you will try some. Okay, so in this first example, we're going to multiply, and we are going to multiply 6 plus 5i and 4 minus 7i. I'm going to show you both methods for FOIL and box. When you solve these on your own in a second, you can do either method. You do not need to do both. So let's do FOIL first. So FOIL is where you do first, outer, inner, last. So first is 6 times 4, so 24. Then we'll do 6 times negative 7i. So that's negative 42. I, because there's an I with a 7. And then we'll do 5i times 4, so that's a positive 20i. And then last, 5i times negative 7i. Well, 5 times negative 7, well, that's 35. But then we have I times I, so that's an I squared. So it's negative 35i squared. So now we need to combine like terms, basically these two terms that just have an I, not an I squared, just the I. So negative 42i plus 20i gives us a negative 22i. Remember, we have this I squared. That means there's a negative 1 right here. So I'm going to just put a negative 1 to help us remember that. So that means we're doing negative 35 times a negative 1. Negative times a negative is a positive. So really what we have there is actually a positive 35. So I'm going to put plus 35. It's a 3. And then that 24 is still in front. So notice we have two terms that can be combined, the 24 and the 35. So when we add those together, we get 59. So we always put the real number first, so that's 59, and then we put the imaginary, minus 22i. That would be our final. Now, it's the same process if you had done the box method. Basically, the box method is just a different way for you to get all of these terms. Once you get all of those terms, it's the same process. Let me just quickly show you box. Remember, box is where you line up the rows and the columns. So in this first box, it's 4 times 6, or 24. And then it's going to be 4 times 5i, so that would be 20i. And then we have, in this row is negative 7i, and this column is 6. Negative 7 times 6 is that negative 42i. And then we have negative 7 and 5i, or negative 35i squared. So you're just lining up. Notice we get the exact same terms. We would combine the two I terms. So these two get combined. And we're basically back to this step where we need to change that I squared to a negative 1, combine, we'll get the same answer. So now what I want you to try is I want you to try this part B on your own. So now let's check part B. You did FOIL or you did the box method, but all of your real terms should have canceled out, so you had 0. All the imaginary terms, you should have gotten negative 13i. So you can write this as 0 minus 13i, or you could just more simply write negative 13i. That would be fine as well. But that's up to you on how you want to write that. Remember, you should have substituted in, if you saw an I squared, you make sure you substitute in a negative 1. So if you have questions on that, let me know. So now what I want you to do is I want you to try part C. It's going to be just like part B, but I want you to try part C on your own. Okay, let's check part C together. Again, you could have done FOIL or factoring. That's up to you. But for part C, your final answer should have been 24 plus 10i. If your final answer has an I squared, you forgot to substitute in the negative 1. But it should be 24 plus 10i.